Okay, I unfortunately lost the first round of this video, and I was doing quite good on it. I'm going to race through it again, and I'm going to do the same thing. I'm going to pause it, plot the points, come back and talk to you. Okay, so here we go. We've got these points, and what we're trying to do is find out what the length of the sides are so that we can determine whether they're all the same, equilateral, or isosceles, two of them are the same, or scalene, just three different ones. So what I'm going to do is I'm going to sketch three different triangles out in three different colors, and we're going to look at them as right triangles with the hypotenuse of those right triangles being the sides. You'll see in a second. Okay, so here we are. We've got these three triangles. If you imagine these as right triangles, because they follow the grid lines, so these two legs are perpendicular, and so we have a right triangle, and we're trying to find out this hypotenuse length. So we can do a squared plus b squared equals c squared, but of course, if you say if you have a squared plus b squared and you square root it, that's the same as square rooting c squared and getting just c. So we can find out what that length is simply by taking the two side leg measures that we know and squaring them and then adding them together and then square rooting it. So I'm going to erase that so we have some room, and I will do those calculations here right now in front of you. Okay, since I'm going to do them anyway, I might as well do them here. So square root of 7 squared plus 2 squared, right, which equals, it's the same as square root of 49 plus 4, or square root of 53. Now if I can simplify it, I will, but that's a prime number. So we have one measure, root 53. That red side, that corresponds to the hypotenuse of the yellow triangle. So getting all that out of the way to do some other calculations, let's do the green one next. And we say square root of 3 squared plus 4 squared. Remember, a squared plus b squared will equal c squared, so the square root of a squared plus b squared will equal c. So we've got square root of 9 plus 16, square root of 25. Square root of 25, oops, is just 5. So we've got a measure of 5. And erasing all that, so we can do now the blue triangle, or the hypotenuse of the blue triangle, really. Okay, so we'll do square root of 5 squared plus 3 squared, or 25 plus 9, root 34. And square root of 34 is actually just 2 times 17. And that nothing in there appears twice so that we can bring it out. So we really just got then root 34. And now let's look at those three measures. Are any of them the same? Well, we've simplified them, and no, they're not the same. So what we're going to do is we're going to just right here, we're going to say scalene. That is a scalene triangle because none of the sides are the same. So I'm going to then plot number 18's points and connect them and come back and examine them. Okay, so here's that triangle, and I'm now going to do the same thing I did, make a yellow, green, and blue right triangle using these three sides as their three different hypotenuses. All right, here we go for this one. You can see that the yellow and the green triangles are the same side lengths, 1 by 7. Okay, so if you do, and we'll just do this over here, square root of 1 squared plus 7 squared equals 1 square root of 1 plus 49, or square root of 50. And 50, that's a fun one, is square root of 5 times 2, and those two 5s come out once, so you get 5 root 2. And actually I'll put that in blue over here, 5 root 2 for that one. Let's get all that out of there. So that's what the blue one measures. Now we just got to check, oh, and I'm sorry, that was yellow and that was also blue. I'm sorry, yellow and green. I put that in the wrong color. My apologies. Let's get that out of there. Oops. and sorry about that, a little frozen. I'll erase that and then write that in the correct color, because that actually matches with the triangle that's in yellow, 5 root 2, and it also matches with the one in green because they're the same, 5 root 2. So we know we're dealing with at least an isosceles triangle, and let's see what we get for blue. Let me get the calculations out of there. Okay, and now we've got 8 squared plus 8 squared, square root all of that. Square root of, getting a little lag time in my controls, sorry. 8 squared plus 8 squared, which, by the way, 8 squared is 64, the square root of that's 8. That's why 8 squared is 64. So you'll notice that we're going to get in here, really, 64 plus 64. Another way to write this is 64 times 2. And another way to write that is 8 times 8 times 2. And notice that you get that 8 in there twice, so you can bring that out, and you get an 8 root 2. In fact, notice that we squared the same number, 8, twice, and it ended up as 8 root 2. That's always going to happen when you square some number twice. If we had 6 there, if we had 6 there and 6 there, we would end up with 6 root 2, because we did it twice, so it's really that 6 squared times 2 like I did down here. Okay. How many sides are the same? Well, we have 2 sides the same, so what kind of triangle is that? That is an isosceles triangle. So I'm going to say isosceles. Okay. Is it a right triangle? Aha, interesting. I didn't check that for the scalene, unfortunately. That was my mistake. So I can go back and do that, I guess. But why don't you just check it, and I'll show you how to check it. So I'll leave it up to you, because there's no harm in you actually doing some of this without seeing me do it, as long as you see another example type of problem. So I'm going to show you how to do that. Okay. Just give it another second so that I erase this. How would you do that? Well, what we want to do is we want to find the slopes of 2 lines and see what they do. And a good sign here is that we've got a 1 and a 7. So, sorry, again, having this weird lag time with this device. This is 1 and 7, and this is 7 and 1, so let's see what we get here. Okay, we have a rise of -1, run of 7. Rise of -1, run of 7. And for this green one, we have a, if we go this way, we say, oh, okay, we could say rise of 7, run of 1. You see that's a positive slope. Rise of 7, run of 1. And you can go either way. You can go, you really want to do the rise first, so let's do that. Rise over run, 7 over 1. And what do we know when we do that? 7 over 1. We actually get opposite reciprocals. And that's what it means. When you get opposite reciprocals, what that means is you have a right angle right there. Okay, you have 2 slopes that are, 2 lines that are perpendicular, and perpendiculars make right angles. So what can we do? We can type in here, oh, let me do that again. We can type in here that it is also right. Great, nice, okay. I'm going to pause this and erase all of this and then plot our number 19 points. Okay, so there's our triangle for number 19, and I'm going to do again one more time. I'm going to make a yellow, a green, and a blue triangle, with each red side being the hypotenuse of that triangle, so we can use the Pythagorean theorem and find out the lengths of those sides. All right, so here we are at this last final bit of it. We are going to let's do the green one first. We'll say 5 squared plus 12 squared, and that's 25 plus 144. I'm sorry, the square root of. This is going to find that length. Square root of 1. Sorry, I'm having lag time, as I said. I write something and the program hangs up. 169, and that roots perfectly to 13. All right, so I'm going to erase that. And I'm going to say we've got one length of 13. Okay, now we're going to do another side length. We've got 8 and 10, so let's calculate those. The square root of 8 squared plus 10 squared, or square root of 64 plus 100, or root 164. Okay, let's see how we break that down. 164 is the same as 82 times 2, and that breaks down into 41 times 2. So we actually get 2 2's and a 41 in there. So I'm going to erase this, and I'm going to say that's equal to, let me erase that as well. Since there's 2 2's in there, we will get 2 root 41. And now finally the blue. And what do we get? We get 13 squared, sorry, the square root of 13 squared plus 2 squared. Okay, 13 squared is 169, plus 4 is 173, square root of 173, and I don't believe that that is rootable. So, and it's certainly not the same as the others. And so we have 3 different side lengths. So we can call that scalene. Now let's see if it's right. And the way that we find out whether it's a right triangle, and I'm going to erase some of this up here to be able to make some space for this. Erase all these. Actually, I should leave in the numbers though. For the lengths, that was 13 and 2. The reason I'm going to leave that in is because we're going to use that to find the slope. Up here, I don't know why. Okay, it's processing. Up here, I don't know why. Okay, it's processing. I'm sorry if that was hanging up here. I don't know why. Okay, it's processing. I'm sorry if that was. Let me see. Okay, I think it was my microphone shorting out, so I'm going to be done with this after this video. But let's do these slopes first. Let's see if we have any opposite reciprocal slopes that will tell us we have a right angle. It doesn't appear we do, but for this slope right here, we've got a rise of -12, run of 5. So we have one slope that is, I'll write it up in black, -12 over 5. Okay, and that was the green. So now let's do the blue. We've got a rise of -2, run of 13. So we have -2 over 13. And for this last one in yellow, we've got a rise of 10, run of 8. And a rise of 10, run of 8 simplifies to 5 over 4. And as we can see, none of these are opposite reciprocals of each other. So it is not a right angle. So we know that 18 is a right angle, 19 is not, and you have to check 17 yourself because I did not do that one. Okay, I'm going to call it a night. It's 7 p.m. and time for me to go home.